theorem of permutations when all objects are distinct. So this theorem is regarding the permutation when all the objects which are given to us are distinct. No object is repeated. So this theorem states that the number of permutation of n different objects. Okay, well, we have n different objects. So the object do not repeat. And we take r object at a time. Okay, so minimum we can take one object and maximum we can take n object. Then the number of permutations is given by NPR. Actually, NPR represents what? It represents the permutation. It is a short form of permutation of total permutation. Total number of permutation of n different objects taken r at a time. Taken r at a time. So this is given by n into n minus 1 into n minus 2 and continued up to n minus r plus 1. Okay. So if we have 5 objects and we have to give the formula for 2 objects, then this will be equal to how much? This will be equal to 5. Okay. 5 minus 1. And this will continue up to which term? N minus 2 plus 1. That is n minus 1. Okay. So the formula will have only 2 terms. So here, if we are considering 5p2, then it has only 2 brackets. So only 2 brackets are going to come. So number of permutation of 2 objects out of 5 objects is given by 5 into 4, that is equal to 20. Okay. Now we are going to see that how this result is obtained. Okay. For this we assume that we have n objects. We select r objects from it. Okay. So since we have to arrange them, so we are going to arrange these objects in some place, or or we are going to number them. The objects which would be selected would be numbered. So what I do, I assume that I have these r places. How many places? R places. So r places are there in all in which we have to arrange these r object. Okay. Now assume that we take the first object. So first object is to be placed in this first place, second will be placed in the second place, third will be placed in the third place, and the last will be placed in the last place, that is the rth place. So number of ways of arranging the first object would be n, because we have total of n objects. So n choice are there for us. Okay, absolutely no problem. For second place, n minus 2 ways are there, n minus 1 ways are there. After placing one object, we are left with how many objects? N minus 1 objects. For the third place, we have n minus 2. Okay, so therefore for the rth place, the total number of ways of arranging would be n minus r plus 1. Okay, so you may see here that how we obtain for rth place n minus r plus 1. It is like this, that for first place we had n object, for second place n minus 1 object, for third place n minus 2 object. So the place which we are taking, third place, so we have a number less than it. So for rth place we have a number less than it. Okay, so actually this is n minus r minus 1, which is written as n minus r plus 1. Okay. So since all the objects are to be arranged, so we are going to apply the fundamental principle of multiplication, and on multiplying all these values, n into n minus 1 into n minus 2 up to n minus r plus 1, we get the total number of arrangement of n different objects taken r at a time as equal to npr, which is equal to n into n minus 1 into n minus 2 and so on up to n minus r plus 1. Okay. NPR, which is equal to this whole term can also be written as n factorial upon n minus r factorial. So actually, the more compact or more useful formula for the permutations is given by n factorial upon n minus r factorial. Okay, so the same as, so if we have to find the permutation of number of arrangement of r objects which are taken from the total of n objects, or number of permutation of n different objects taken r at a time, so we don't have to say n into n minus 1. So this is somewhat difficult to speak also. So this is equal to n factorial upon n minus r factorial. Okay, so factorial can be written as this way or this way, so both mean one and the same thing. Okay, now we are going to derive this formula also, that how do we obtain NPR as equal to n factorial upon n minus r factorial. Okay, so already we have studied this result, that NPR is equal to n into n minus 1 into n minus 2 and so on up to n minus r minus 1. Okay. Now what I do here is this, that I multiply and divide. I assume that this term which doesn't have any fraction as upon 1, and after this I multiply this by n minus r factorial. Okay, n minus r factorial. So n minus r factorial represents what? N minus r into n minus r minus 1, n minus r minus 2, and so on up to 2, so on up to 3 into 2 into 1. So it is going to complete the series of the product of numbers from 1 to n. Okay, so this will be equal to how much? So this will be equal to n factorial upon n minus r factorial. Okay, so this is how we get the result, that NPR is equal to n factorial upon n minus r factorial. So this is how we prove this result. It is very simple too. It is very simple also. Okay, so there is a one-liner proof. What else we can expect from this? Okay, so this formula n into n minus 1 into n minus 2 up to n minus r minus 1, that is the number of permutation of n objects taken r at a time, is same as n factorial upon n minus r factorial. Okay. Theorem on permutation of objects when repetition is allowed. Okay, the theorem is like this: the number of permutation of n different objects taken r at a time when repetition is allowed is equal to n to the power of r. Okay, so if we have 5 objects and we have to select and arrange 2 objects and the repetition is allowed, so this will be equal to how much? 5 to the power of 2. Total number of objects are n, so 5, and we have to take 2 objects, so this will be equal to 5 square, that will be equal to 25. Okay, now how do we get this result? So we assume that we have again these r places, 1, 2, 3 up to r. Okay, and we have n objects. So for first place we would have n, how many options? N options. For second place we are going to have how many options? Again n options. For third place n options, and for rth place we are going to have n options. So the total number of options for total number of ways of filling the first place, second, third place, or the last place, that is the rth place, are going to remain same, that is equal to n. So the number of permutation in this case by applying the fundamental principle of counting would be equal to n into n r times. Okay, so this will be equal to how much? N to the power of r. So this is how we get this result. Okay.